Hello everybody, welcome to another stream. How are we doing? Hey there, Enumerate. How you doing, sir? Welcome, welcome. So last stream we wrote this CSON writer. This is basically a C version of JSON. Because why not? So we basically write out. We have these sort of helper functions which allow us to like begin writing a structure or begin writing an array, and write a uint or something like this. Write a field out, right? So basically we took it for a test drive inside the encoder generator file, which, so this is basically what it looks like. We're going to be code generating functions that kind of look like this here when we code generate a CSON writer for a structure called structure field. And it's two members, type and identifier. And then we will end the structure. So be like code like this. So this is just all in line basically. We do that for a test drive. And if I run the encoder generator, which will generate nothing right now, it just parses this file here and prints it back out. But then it also generates the CSON file for now. So here is the three data types, the internal structures, but we've sort of serialized them out as text. The CSON file, there's this internal type called struct type, what line it was at, column, in hexadecimal for some reason, the identifier, the fields, all the fields laid out on one line. So we're going to parse this up now by writing a CSON reader and then turn it back into actual in-memory data. So should be good. And then that'll be the text serialization format completed. And we can move on to the binary one. So, see, maybe I should have made a text writer because we're going to be using a text reader like strut, which basically stores all the line information and the text in there and everything. And has utility functions. Whereas all the utility functions are... Yeah. Maybe we should. So we've got time later, maybe we'll make one. This is a CSON reader. And it's only going to have the text reader in there. What else? Let's bust open this Pepsi Max. Oh. Hey Alex, welcome sir. How are you doing? How you guys been? Hope you're having a good week. Amazing. See, I think we can get rid of the rest of these lines. And we can start writing the API. So with this API, we need to go over a CSON file and, parse up bits and sort of kind of get back data to tell us what type of thing we're decoding, right? And then we can switch on that. And then, we're decoding a strut, go and do this. Or we're decoding an array, go and do that or something. And then when we're inside an array or a strut, we can parse each field manually. Wait. Sorry, then we parse each field and get back like its identifier. And then we need to be able to operate on that. Yeah, we need to be able to like get back the key and the value, maybe something like this. So let's think about an API for that. Well, first of all, we need an initializer. So it'd be like the text reader initializer, but with a bit of CSON in there instead. The file path, the text, and the capacity. What's up, mate? Hope the stream goes well. Working on some file I/O and parsing today, so I'll be obviously looking. Awesome. Sounds pretty similar. Well, what are you parsing? Appreciate it. Yeah, it's gonna go good. Shouldn't be any surprises this stream. So no, that's so good. So the CSON file. Yeah, you don't put the type name there. Oh, that's because it's an array, isn't it? Right. So you first say see, if it's an array, we don't know the type. Maybe we should always encode the type out. Like, well, we know what the root type is of this file. It's an array of strut type, right? But so we should be expecting it to be an array. And then this one we're expecting it to be a strut type. So when you access a field, you want to get the key, and then you want to be able to say like next field key, then next field value or something, or maybe like read event value. Doing it to this one, you know it's an array. So you then say ensure it's an array. Right, or you can say ensure. Right. Right, maybe that's maybe that's the API we're gonna do then. Maybe that's it. So you say like strut start or array start. With the reader. And then you pass in like the type name. So I can work on some chess stuff. Cool. Oh, chess engine stuff, right? So you're in. Nice. I've never really thought about that type of problem. Interesting. Reading in the source text to see if I can get some good input. Got error messages working miraculously. Cool. And experimenting with inline and some assembly routines. Ah, you're using your own custom language, isn't it? Yeah. Man, that's good. Pepsi Max Cherry. Such a good drink. See, the end would just do the close bracket or something, and ensure that is there. If it can't find it, then it's a parsing error. So I think so. There isn't really so the way we do errors for the JSON writer is if we run out of the buffer, For the destination buffer, we simply crash. So, maybe we allocate like 1 MB. And that ought to be good enough, right? But really, there should be a way for us to be like, oh, wait. Yeah, I think we simply crash. Yeah. But maybe there should be a way that we gracefully fail. And then, yeah, but what else would we do? We'd just be crashing. Anyway. Hmm. Well, I guess, what you could do is you try and write out someone's save data. You failed to save it because of a buffer overflow. And you report that. And then the game can still be running. But still a pretty crap situation. But if we've got like a certain asset that we're trying to save and that fails to save, then yeah, it'd probably be good if we return an error somehow. Oh, excuse me. Yeah, so really for JSON Reader, we should have ways of trying to read like if the input is invalid, maybe we should have a way of saying that. Right, I'll be right back as you to maybe. Right, welcome back everyone. Oh, right, sorry about that. Yeah, I've been waking up a bit early for the past few days because the boy's been waking up early. So I don't really get the best sleep, so I have a bit of a runny nose today for some reason. But it's only just started coming down. So I don't know what's going on. Yeah, so we read a strut and say if we read we go, hey, we're reading a strut and it's the single strut type. But the syntax is a bit invalid, right? Imagine it's missing that. So we fail. You know, I guess this is why you sort of like Lex or tokenize something. So things syntactically will sort of make sense, right? You can ensure that there is matching brackets at least. But no, it'd just be making sure the lexing is valid, not the hmm. Well, I guess if if it's an invalid, we can just set in the reader. We can just let it carry on. Yeah, we could just set in the reader like where did it happen? That was wrong, right? We can encounter like yeah, we'll have like a result. CSON reader result. And the obvious first result is success. You guys headed to winning in the UK? Yeah, UK is always, or well, yeah, it's always like got potential just to rain and stay rain. How'd you upper in this? There we go. Hey Davros, welcome, welcome, welcome. Success. And I guess we could say like error. Yeah, we can work on the errors, right? Error something. And then I guess you have like a we'll have like a lookup table somewhere where you can convert that into a string. Or maybe we don't bother with a damn result. We just have a char star in there, and just be like error message, and if the error message is set, we want an error, right? And then I could just do it in line in the code. You know, there we go. It saves me writing lookup tables and an enum and things. So I guess if we have an error message, we just return some kind of default value that tries to do nothing while parsing, and then we'll just run the whole reader over all the code still, so we don't have to worry about doing early exits. Maybe. We'll see. We'll see how it looks. But yeah, I think we should start doing like proper error handling at least, because it might be helpful for the game thinking about it now. So start, if you come across an array, or if you select an array, you can do array start, and if it fails, it'll set the error message. So it's a little bit confusing, but because of the thing I decided to serialize. But I basically just serialized. So this is a custom file. It's a bit like JSON, but it's with C syntax instead. That's all it is. So this is the data type of this structure. So it's just like the C compound literal. So we've just serialized out a structure called struct type, because in my encoder I've got a I've got to set the language. This is a custom encoder file, which basically again has C-like syntax. Allows me to declare custom types that I want to serialize to text or to binary, and supports extra features on top of C. But I've got a parser which parses this up. And we have a data type called struct type, and I'm testing out this CSON writer using the sort of parsed information from that encoder file. And then we're writing a CSON reader to sort of deserialize it, you know, to decode it. So that's what those are. So struct type, if we go to the generator itself, which has the parser in it, just to peel behind the curtain a bit more. The struct type contains like the identifier of the structure, and it's got an array of fields, and the fields have a type and identifier, right? So it's just type information for a structure. And they can have default values if they're a table. But yeah, so that's what the difference is. So I think maybe we do basically have a similar API, but it kind of just goes the other way maybe. You know, then you can say read reader. So you're saying, so you're not saying, hey, I want to read a field. You're saying I want to read a value. So really this needs to be taken back to the front. And then we probably need another function which basically says what is the next field thing, right? So you want to say yeah. So that's part of the reason why we're doing this CSON thing. Is so we can map, like we have the type names in the file. If we just use JSON, we have to it's kind of a bit of a guess what the types are at times. But you know, when we give this to the decoder, it will already have enough information to deserialize it, but it's just better for when you're reading it back, I find, like as a human looking at it. So we also want when you're inside a strut and reading a strut, you want to be able to go, hey, what's my next field? And then when you get back the string, you can compare the string or hash it and compare the hash and just be like, oh, maybe we'll have a read hash one as well. Because I might just be like, well, a hash is good enough, right? Just pre-hash it for me and return it, so I don't have to keep writing that code again. Yeah, we could then just be like, oh, we're decoding the identifier field, so I know now I need to read the string. Yeah, so that's pretty nice. So the next one will be reader. We also want to be able to read an array element. So with an array element, there may be, so with CSON, if it's an array, so this is an array here, we support designated initializer syntax. So we write out, what do we do? Yeah, we support serializing out things wrapped in these brackets, which is a valid syntax in C. So we could really support some enum value as well here. But reading that back is a little bit weird, but we could maybe support it. And we could say next. Like, so next field. The next field hash isn't going to be useful. Because see, for an array. Well, it does come back as a number. Yeah. So I guess if you're parsing an array of something, yeah, we can just use the field thing again. Yeah, this is it. This is the API. So let's go and implement it. Oh, yeah. It's gonna be amazing. All right, looking good. Yeah. Did somebody copy paste? Right. So our text reader in it. File path, text, and capacity. And then we just instantiate the error message to null. Wait just 1 minute. Using Helix now. Why switch, brother? Hey, Spike Funk. How's it going? Well, basically updated my operating system and it errored like crazy. So I came off near them. I could have probably tried to fix it, but I couldn't be bothered. I had a big config at that point. And I was hoping. 1 minute. And I was hoping there would be a better, a modern take on a modal editor. And Helix seems to be that. It's not perfect, but I do like how set up it is out of the box. There are some things which I wish they had in it, but I do like it. I'm still getting used to it though. Just been finding my way around shader node tools in Blender. Looks super useful. Yeah, they got quite a suite of things, and also with the shader nodes. If do you have a custom export script for your like in Python? Like you could basically traverse the node tree in Blender in Python code. It's a bit weird, but you can do it, and you can basically interpret the tree and export that out. You could support a subtree of their material shader node thing, and put that in your game basically. Well, you could export that into your mesh and then load it into your game quite easily. No, I didn't lose the dot files, just something with the plugins messed up. I know you had Crazy Vim bindings. Yeah, but that wasn't necessarily, that's just, a remap. All right. So I did the same thing again. I did a good old crazy remap, so I got complete custom keyboard layout. So it's been a while to learn because I only do it, 4 hours, 3 days a week. But I'm getting there with the learning of it. That would be ideal for the moment. I'm just finding it useful to be able to get Blender like view of things I have in game. All right, yeah. So you can see how it looks in Blender without having to put it in your game. Yeah, that's the thing you can do. In my quest to avoid bloat in web apps on Windows, I have came to the conclusion that's Sublime Text, great, and Red Debugger is the best setup. See, Sublime Text is that editor where I'm like, why do people move away from it? Because Visual Studio Code is like, it's a web app. Able to edit stuff that matches in game. Right. Oh, right, I see. Yeah. Right. Yeah, Red Debugger would be good. I'm waiting until that comes to Linux, personally. I think at work we use Visual Studio. But yeah, as soon as that gets good at work, I might Give it a go if it works right. But I don't know if it'll work. We'll see. It's pretty cool, isn't it? Rad debugger. Because maybe I'll be able to come off Visual Studio at work and move to Helix. Be pretty neat. So when we get to the start here, we should be able to say skip a white space. Text reader, skip a white space and new lines. Get them out of there. And we'll pick up that next character. It'll be like A. A U. A open bracket. Oh, I meant to take the address. Been a bit of a wally. And then, if that is not true, we set an error message. You're like, ugh. Expected a... Well, this is not really correct, but anyway. Expected a... begin the structure. That'd be nice. And you return. Now, so we also want to be say, right, if there is an error message that's already been set, we're just going to return. Right, and just don't do anything. Maybe. We'll see. We'll see how this goes. But yeah, we're actually meant to read a bit more before. Text reader. Like an open bracket thing. Reading the strut type. Now here's where you actually read the strut type. It's supposed to be the let's call it T, I don't know. So we'll say text reader text reader read until. Now a bunch of dilemmas. The dilemma is probably that. Or let's do some brackets as well. Or a space character, to be fair. Maybe a tab. Maybe a new line. Yeah. So here we'll say, well, if for string compare equal T and type name, so they're not equal. We're going to set another error message where we're going to say, you know, type mismatch. So I think, right, we should just, when we do one of these sort of like CSON readers, maybe, just maybe, we need to have like a max error message size. And we just simply, I don't know we could do 1 KB, right? What's the problem with that? It'll probably be on the stack. Then it won't be a pointer anymore. Problem. Yeah, that's right. Doesn't have to be a pointer. So it's always configurable. So instead, we'll just instantiate the 0 first byte to 0, or a null byte. Same thing. And here we're saying if there is an error, as in something's been written in there, then fine. So here we're going to write out an error. So it'd be sn printf. Now, a bit silly. So maybe we should do the whole make your own custom function. CSON reader char star const char star format dot dot dot. Then you do the sort of special printf check thing. For printf 2, 3. So this means we get proper error messages if we pass in the wrong arguments into the format fields, like printf does. But so this is a special thing in Clang you can do, and GCC looks something like that. But I haven't actually enabled it just yet. It's actually disabled right now, I think. No, it's not. I forgot where I disabled it, or did I go and fix all the errors? I don't remember what pass me did now, but anyway. It's pretty neat. So here we do VA list, VA args, VA start, the list in there, and the last argument. Then VA end, VA args. And then we can do all the fancy stuff. So it's VSN printf into our error message. Size of our error message so it doesn't overflow. Pass in the format, and then in goes the VA args. Jobs are good. And so now we've got this little custom function which allows us to record the error message. And it'd be nice and easy. So just CSON, reader error, pass in R, pass in the format if we have anything else in there. Might as well put it in here, right? So int casted, type name, size, type name. There. All right. We could say, but got this other character. Char. That'd be pretty neat, wouldn't it? So you gotta say like text reader text plus or index r text reader cursor. I'll do it. Damn. So we might as well break this up onto some more lines. Make it a bit easier to process. Right. Looking great, isn't it? So we'll just simply I love Sublime being able to write custom build commands and just write and just compile a touch of but we'll also that on the system. Excuse me. Hello. Right, excuse me then. I love Sublime being able to write custom commands and just to compile a touch of button while it's on the system. Yeah. Exactly. I don't know why people really switched away from it. I guess apparently there are people saying like plugins were better on Visual Studio for some reason. I don't know. Probably a web dev thing, to be fair. Hey Kappa, welcome. Can you believe there is people who think Diet Coke is? I know, right? Diet Coke does always taste so like the sweetness of it is weird. But to be fair, I prefer the Pepsi Max. Like Pepsi Max, cherry, mango. All the Pepsi, just done a Pepsi Max. Is the sweetener in there is like a sort of that sort of aftertaste is like it's like a sherbety taste, and it's so nice. But yeah, if not, Coke Zero is a second choice after Pepsi. Yeah, Diet Coke. I think it comes from the generation above me. You know, the like the millennials, maybe. You know, yeah, because that Diet Coke when they were sort of, hard at work. 1,100 packages. What the crap? Bananas. What have you done? Just included the HTTP framework or something? that's that's crazy. Ugh. Right, it's not found. Right, let's include it's standard string in it. I'm just getting these damn errors. And I'll do it. Okay. Yeah, mem copy, mem compare is in standard string. Right, so we'll be able to say like, oh, we expected a expected type. Expected the strut type. Blah but got blah. Nice. Keep going. So the other one is this one here. So you would do an open curly. So expect an open curly to begin reading the strut. This. Got that. The strut fields. The fields. Yeah, just make it read a bit different. Good, isn't it? So that will read that, and then we can just keep going. We've got this thing where we say if there's been an error message recorded, we'll just do nothing. We'll see how that goes. So we'll do the same thing again. Probably something like that. Drop it in. Hey, Glorious Sir. Yeah, doing good, man. Not doing bad. Bit of a crazy day yesterday, but today's been a good day. Yeah, pretty chill. Got a bit of runny nose for some reason. I blame it on having to get up a bit too early and not getting good sleep the past 4 days. Maybe. Or it's because I drank 3 Pepsi Max cans yesterday. Yeah. How about you? How are you doing? So we expect, after skipping a bunch of white space and new lines, that we end up closing one of these. Now, there might be a comma that we come across, because we also support trailing commas, right? So they're probably going to be a trailing comma. So we can just go A. You should assume the comma if there is one, but don't tell us if you did it or not. We don't care. And then, yeah, but this one we expect to be there if not fail. To finish. Now, we haven't been encoding the line numbers in here. So, prepare for something awesome. And also, VA list, I guess, yeah, we only really use that in C to extend print format. Please someone put that in the... Oh yeah, Hostman, yeah, rest side for VA start. Yeah, it's barely used. Only time I use it is for print formatting. Yeah, I think what we can do is this. We can actually just say error and encode it into the error message, and then we just print the error message out if it exists without any special about it. So I should be able to say printf error file line column. New line. Yeah. Yeah, but then it's going to be a bit much, right? Yeah. Yeah, otherwise we're taking up a lot of space inside the CSON reader's buffer. So, but maybe it's fine. You know, we'll see how it goes. Tuck it in there. smprintf. Yeah, so now we'll get back how many things that it wrote. We'll call it an offset. This will say how much space it used, how much it wrote in there. Not included in the null terminator. Reader, text reader, file path, reader, text reader, line, reader, text reader, column. So we should be able to then say offset. Start writing at plus offset, which will overwrite the null terminator, and then obviously remove that much from the size of this. Right. And boom. So that'd be pretty nice. Um, cool, so that's an end structure one. Looks alright. So now the array is going to basically be the same as the structure one, but it's just not really going to contain any type checkings of any type checking, right? So we just get rid of these two lines here, and we just do the open bracket, and we just say the elements of the array. Right, and then the end array is going to be the same as end strut, just maybe changing the word strut for array. And then yeah, now into the meaty part of the CSON reader. So this is like, you know, reading the next field and then reading the field's value. Might be the kids since their immune systems aren't sophisticated yet. Potentially. It's not got a cold though. Yeah, sleep is a rough thing. I'm good. Slow-paced code grinding and wasteful, nostalgic MOBA play. Oh, okay. Interesting. What MOBA? Like Dota? Or something else? So after we've read, and we start beginning reading the fields, obviously you always skip a little bit of white space first. And, you know, could we handle the error message thing properly, right? So if you get back a field and you get back something like an empty string, right? If you get back an empty string, well, I guess we could just leave the function, right? And then we don't end up parsing any of these fields, right? Yeah, so when we're deserializing a structure, we could code gen and say if the field that we get back is an empty string or the hash is 0 or something, then just simply return early, don't bother decoding anything else, and then it will keep bailing back up and up and up automatically without having to put too many if statements everywhere. Right? But yeah, the if statements are kind of inside the checks, but that's okay. So here we'll turn string null. Go string null. Take a string null. Neat. So after you've read this, it could be an array or it could be a field actually. Whoops. Right, let's just do the strut one for a sec. Like maybe we gotta be like, you know what, maybe we gotta be like the writer where we maintain the state. And know if it's an array or not. With this sort of like is array bit set stack thing. So I guess we'll do something like this. Quite easy to do, to be fair. Not a lot of work at all. So just instantiate it like so. Bit of an R instead of a W. Then it's going to so when we read the start of a field, we know how to parse it. Pretty easy, I reckon. Any other places where we need to, obviously we need to, when we start a strut, we need to OR our bit on and then increment. And then, so the increment function would just make sure it doesn't overflow. So I guess we've got to do some of these guys as well. Um, um, right, corrected that. So indent increment. Cool. We need an indent field as well. So the indent will be used to only track like um this is an array or not. Like yeah. So when we read oh where's the type name in here? Cool. So when we do a read field, if it's an array, we expect it to be open array brackets. That. Well, no. We either expect that or we expect. Oh, this is interesting. Or the value. Alright, let's have a think about that one. Watched a bit of Dota tournament and decided to try Deadlock. Oh yeah, the new Valve game. Interesting. Is it any good? Yeah, so if you come across the array, so it's just like C designated initializers for arrays. If you come across, if you're in an array, you will come across like, let's go to the CSON file to have a bit of a play with it. So if it's an array, you can expect more array literals. So curly brace open. You can also get one of these open. You can also be getting like numbers if it's a number or a string, right? So I guess what you want to say is if it's not this character, then just don't worry about it. Just um return nothing. Return an empty string. But then if you return an empty string, it's not going to work with that error message thing we've just done. But it is kind of true, right? No, null is different from an empty string. Yes, we can return an empty string. So that would be different. So specific. But yeah, so if we don't have this character, we're going to return a core string from a C literal. Empty string. So that will return a null terminate empty string. So you can't error on that. Whereas if it is not an array, then we ensure that there is a dot there. So this one we would expect, so we get rid of this error now. String null, I guess. Expected a dot. So you always have to put the field names down. To start reading the next field, right? To start reading the next, the strut field identifier. We got this. Good. Right, so now we've got to a place where we parse an identifier, and we would like to then, so where is, well, we've done that before, it's here, isn't it? One. It's the ident. So basically at the end of the thing, we want to return the ident. And now if it's an array that we're inside, what we need to be doing is ensuring that there is a close. After we do skip some lovely white space and new lines, though, that is, mind you. Never forget those. To finish the array element ident. Yeah. Right, so it's good to do like that. So one thing we did quickly forget, and that is the indentation stuff. So yes, when you begin a strut, we want to remove the isArray bit and then increment. So strut start, the end of this one. Let me just get my boom. Yeah, so it's like a bit of a W. Change that for an R, and the writer for a reader. Then for a strut end, I'm pretty sure we just want to decrement it. Yeah, it's a dec. So you just decrement the indent so that this indent would be less than 1, and then it can read out whether or not the structural array outside of us is a strut or an array. So the final one is the array. When you start the array, we need to put in that bit to say it is an array, rather than remove it. Nice. That's pretty good. I like it. Right, so next thing is doing the field hash version of field. So we just return a hash of that field instead, because we don't really care about it being a string, because we want to just compare hashes or something. So it's a convenience function, and then we can implement reading the field values. Back seems like Z finally finished compiling. Awesome. Oh wait, you're compiling a new fresh version of Z. Fair play. How are you finding Z? You enjoying it? I do consider like having another play with it. Because part of me was thinking like, oh, it's taking me ages to learn this editor. I would love to just be a little bit more speedy, but I feel like I'm getting better at it. I need to just dedicate more time. I'll get the gist. Oh, okay, it's run out. Fair play. See if we compile it from source. Well, I think it's interesting enough, but I can't say for sure. Visual design is nice. Game design clearly tries to avoid Dota's exploded complexity, but keeps some depth. Community is a mess already. Dirt players, I guess, right? Yeah, it's quite an interesting technique they used, right? The whole sort of like, come and join the secret club and get access to the game. You just have people had to put a bit of work to get access to this free game. You know, try and find someone to get an invite, and then once you're in, you feel like part of a bit of an exclusive club. Quite a good little technique. And they also kept it quiet from the press until that guy spoke about it, and then they deleted his account or whatever it was, banned him. Good times. I feel like if you do games these days, you got to do something a bit. You got to have something that's not ordinary in your game if you want to help with with the success of your game, and that's one of the ways you can do it. Oh, I did it in 2011. Oh yeah, now you say it, that's kind of makes it does kind of ring bells. Yeah. Right. So if the identifier is right, it's got to be a specific one, right? If the data is equal to null, then you will return a special hash, which we can known as 0. So if the hash is 0, then it's a we've obviously encountered an error while parsing, and we'll just bail out the whole deserialization of reading this strut, and all of them will terminate one by one. There's one place where you can put the if statement rather than every place that you try and decode. Then we can return. We'll probably do a bit of an FMV hash, you know what I mean? Hash 64. We can always change it. That's why I've written this function. Ident data. Ident size. And you got to use the base initialization constant. These are found on like the Wikipedia page. You initialize it to this sort of, I think that's a prime number. And then there's another prime number, but yeah. You can't start it on 0, so you start it on that hash. And then you can keep hashing a bunch of stuff and accumulating the hash value. So it's kind of cool. If you wanted to. Oh wait, this is the dumb way of doing it. You should also hash the size of the string as well if you want it to be distinct. Yeah, you want it to help be distinct. You also hash the size of the string. So you go, so you go address of ident size, and then size of whatever this field is. So that's a U pointer. So yeah, hash is 8 bytes. Off it goes. Probably a bit overkill, to be fair. We can always change it. There we go. So that's the field, being able to get access to the fields. So now we're talking about like reading events and stuff. So we do have. So I've got a text reader thing, right? And text readers that come with ways to read. I think it does. It didn't really come with ways to read things, like numbers and things, did it? I had to parse numbers manually. But yeah, what we could do is, wait a minute. When we start a field, we also want to parse the equal sign, isn't it? It's better the equal symbol to the for the begin the next field value for this. Yeah, so it's missing that. Right, so now we're actually at the value. We can now decode the value after we've switched on the field name and know what's happened with decoding. Hey, Devastated. How am I doing today? I'm doing alright. Got a bit of a runny nose right now for some reason. It's just really picked up. Very convenient. Probably due to lack of sleep or the fact I had these yesterday. They were so good. Yeah, too many. Maybe that's it. Maybe it's the combination of things as life typically is. But other than that, doing pretty alright. Excited to get this CSON reader done today. Come up with a good design, I reckon. And we might put some error messaging, error handling in the JSON. Sorry, CSON writer. Oh, JSON. Have I played in MOBAs? I think I played a MOBA briefly with my brother once, or maybe someone else. Yeah, I only played it once or twice. I know the idea of it. I also played like a lot of the arcade stuff in StarCraft as well. Like I played StarCraft 2, but I was like terrible at it. But I played the arcade like way more because it was like quite a lot of fun. But yeah, that's basically my exposure to MOBAs. So it's not really too much. I was just never really good at it, so I just kind of gave up. Yeah, I don't think I got too much of a cold. Maybe I don't know. Doesn't feel that bad. If I got a run nose tomorrow, I need to get some proper tissues because it'd be quite a bad experience not using tissues. Just gets really sore, you know. So yeah, reading in int quite easy. C standard library has you covered. Probably better if we rolled our own at some point, but we've got to get stuff written out. So we're going to use the C standard library. So we'll just read an unsigned long, right? Or an unsigned long long. So it's 64 bits always. A quad word integer. Yeah, so we'll just throw in the text reader plus text reader cursor. So we'll start reading from there. And then we're going to simply get back a pointer where it ends. So start pointer, char star start pointer. Nice. And then we'll write end pointer. Yeah, what's funny about this, right? I always thought this is dead funny. Like string to unsigned long, it takes in a pointer to a const piece of memory, right? And guess what it returns to you via this double pointer? A piece of mutable memory. It's like, why? So like, so silly. There's probably a legacy reason for that I don't know about. And then the radix is 10. Wait, the radix is whatever you can figure out to put 0 in. So it'll support the 0x syntax automatically for us, which would be pretty sweet. So I don't know what I did there. Okay. Anyway, then it will return to me a something. What was it return? Oh yeah, obviously returns the value. So here's the value. Ta-da. So there's a very special case. So if you man a bit of this, we can figure it out. So it returns you long max. Or UL max long long max. And it sets error node to E range or something like this. If it's an invalid parse. But it also just modifies the... Wait, did we handle that properly in the... Oh yeah, we already guaranteed... Yeah, verified it up top. Okay. This one we're not pre-verifying the value. We are instead... Right, so then pointer is not null, and the base pointer is supported. Sorry, and the base is supported, as in this one. Store returns the address of the first character, first invalid character. If there are no characters at all, stores the original value of the start pointer and returns 0 in particular. Oh, yeah, so if it's equal to the start, that's a problem. So it can't be equal to the start. In particular, if the pointer is not 0. If the start is not null terminator, but end pointer is null terminator on return, the entire string is valid. That doesn't matter for us. So yeah, we've got to say this not equal to start pointer. And then we might have to check this thing as well. So let's write that in so we don't forget. Is equal to end pointer. That is an error. Or there might be another part of the error. Returns either the result of the conversion, or if there was a leading minus sign, the negation. if the resulting conversion represented as an unsigned value. That's cool. That's what C does anyway. So we can, it's great that it supports that. Unless the original non-negated value would overflow. Okay. In the latter case, returns ulong max and sets error to E range. There's quite a long number of overflows, but yeah. So I guess this one would say like, you know, it would not be a number. If this is equal to that, we've not read a number, where it's not a UN. But the other one would be an overflow error, so technically we should have separate things here, right? So we could set an error and read back a value, but the next one that we read, the next field that we read, it will return something to say that there has been an error, and then it will bail out the function. This should be fine. Just return 0, right? Doesn't matter. Or return. So this is saying expected a number here, expected an integer, unsigned a unit here rather, value here, but got this. Cool. So the other one is saying expected we could say error uint value has overflown a U64, right? Too big. It's pretty sweet. Yes, this one, it will set it to a value of 0. Well, no. Yes, error no would be set to E range. And right. Div returns U long max and E range. Div value equal U long max. And error no equal E range. That'd be somewhere, I don't know where it is. Right, so this would be like it's overflown. Awesome. So the final one is we actually need to now advance the text reader by the int that we've parsed. So we simply just call text reader advance by, take in the address of the text reader, and then we advance by end pointer take start pointer. Like that. And then we simply return the value. That's how you parse a string to be an integer correctly. Then the unsigned, so the signed version is very much the same, just without the U's in places. It's looking all right. And the final one is the float, or the final number one. So you just say string to D for double. It doesn't take a radix in this time. And expected a float value. Here, we got this guy, radio. Looking good. What is going on? That should have been a... Right. Float 64. So if this one fails, What's the pages say for this one? String to div double. This one's saying NaN maybe. If no conversion is performed, 0 is returned. Unless start endpointer is null. Um, the value of the start pointer is stored at end pointer. Excellent. If the correct value will cause an overflow, plus or minus huge value, right? Val f, huge val f, or huge val ll is returned according to the return type and the sign of the value. And E range is stored in error. Right, so it's a similar kind of setup. We're looking for plus or minus huge value. So if we ABS, yeah, absolutely. Well, that'll be right, wouldn't it? Yeah. Right, so the next one is the string. So for a string, really we want to, I guess we don't want to accept any new lines in these strings. So we should, yeah. So I was thinking actually we have forgotten to include this no space, skip white space or new lines in all these places here. So let's just drop those in quick. Cool. So we want to do that quick check where we say if it is a quite, then, or if it's not quite, then we expect a quote here. Begin reading the next field or something. Oh. Or to for a string value here, but got this thing. Nice. For the start of the string value here, for the end of the string value. So my concern is like we want to read until. So we're not going to be able to parse. There's like escape sequences and things. We have in the CSON writer we haven't actually escaped the string either. We just wrote it all out. So it's a little bit funny to be fair. But we should probably we should probably handle that at some point. But I don't think it's going to actually matter right now. So we'll just simply do that read until syntax. So we'll just read until there's like another quote or a new line. Yeah, that'll do. There are a couple of terminators. That's what we'll return. Now, we expect the next character though to actually be a quote. If not, it's a fail. Cool, so I think that'll do that one. So for the enum, we're just going to keep reading every bit of alpha and numbers really, and underscores. So we could do the read until, but we could also say keep reading. Maybe I should make a new one called like read while. Or read ident. Because we've passed a whole bunch of other idents anyway. Maybe. Yeah, we'll just do this one. So here's the value of it, right? Don't know why I'm not just calling this value as well, to be fair. Um, right, so we're just going to read up to the JSON reader enum value. What should we read? Well, there's going to be like, well, there could be a comma as well. Yeah, we're just going to read up to maybe a comma, close bracket, or yeah, just stuff like that, really. We could put some extra characters in there, but that should be okay. Right, because we go to the CSON file. If you have an enum in here or something. Yeah. Right, then we'll just return that. I think, so it's your job to take the string and compare it and make sure it makes matches or something. Maybe we could do the same sort of thing when we do like enum hash. And I'll just hash the enum string. Yeah, Yeah, maybe we'll do a similar thing. So these values here, you'd only call this value function if if the last thing did not error. Yeah, so I guess all we need is this. U64. So reader, I'm going to read an enum. And that's the actual value this time, not really an ident. So pre-hash it up so we can just compare hashes rather than strings. Make things a little bit quicker. Yeah, so I guess we're kind of finished now, which is pretty sweet. What I would like to do is just think about the naming quickly of things. But we're in a pretty good place. So it is a bit misleading calling it, reader enum, right? Because you might, it's okay. Okay, I reckon it's all right. So I guess should we just start trying to use it now, right? So we've already written out this super lovely CSON file. We've just taken some data types from the parser that we've written for the encode file and just basically serialized out to the CSON file. So I've got the CSON reader now, so let's just try and turn it the other way around. See what happens. So we go to the encoder generator. So it flushes it out here. So I guess we can so I guess I'd like to do something again. Right, where are we gonna go? Okay. CSON reader R. So I have a char CSON buffer. We'll do another one. We'll do 64K or whatever, I don't know. Ought to be good enough. CSON reader. I'm gonna read in initialize it. R CSON buffer. Right. So we need the file path test.cson capacity. Wait, it's the wrong way around. Crap. So the capacity, how much do we actually read? CSON buffer size. So we need to actually read it in. So you pointer CSON buffer size equals core OS file read all or OS file read all. Yep. So test.cson, and then we're going to read in to the CSON buffer, and we've got a super lovely size out CSON buffer size. Right, because it actually returns an error, but ain't nobody got time for that. What am I writing? Yeah, the tribe chief. So the basic thing is we run a custom encoder and decoder system, which is going to be used for a whole slew of things really. So this custom data format, which is basically as C as we could get it, very C-like, with a few extra little features. And the idea is that we could take this file, parse it up. So we've got the parser already done. And we can encode any of these data structures out into text or data by code generating the necessary code to do so. So what we're doing is we're writing some utility functions to help, obviously not have to code gen too much spaghetti code. Instead, we'll just call into some standard functions like, write out text, read text, that sort of thing, or write out binary, read binary. Some nice handy functions for that. And overall, this system is going to be used for writing out files, a versioning system for them as well, encoding packets to send over the network when we do multiplayer, and it's going to be used for GPU to code generate packing data structures into as smaller bits as possible without writing the actual packing code. So I've got these like little things here, like ways of packing integers into a smaller space based on the start and end numbers, or packing floats into a smaller space by saying I want to use 8 bits and here's the range. These are terrible examples, but it's just testing code, right? So we should be able to use this for like packing network packets down, like quantizing, and also packing GPU buffers down to small areas as well. So it's really like a system. That's why I'm calling it an encode and decode system, because it's literally just about transforming data from one form to another one. But yeah, it's going to be used for the different places where that ends up happening. Networking, files, and GPU. Did that kind of give you a good idea? Do you need any more? Very interesting. You have a groovy stream going on. Thank you, sir. I appreciate it. I don't know if you. Let me give you a bit of tour of the game as well. So we spent a lot of time doing rendering R&D. So we're just like ray tracing a bunch of ellipsoids, and we're going to be building a little level and an editor to actually make these ellipsoid models, because right now they're just programmed up to be these little like snowmen things for some reason. But yeah, it's gonna be like a top-down RPG game, but I just got to get. I want to get obviously the core parts of the engine all in. So I'm just making sure, because we're building everything in the game. I want to make sure that the data encoding stuff is good, because we're going to be creating actual files that we want to preserve. So yeah, that's where we're at for now. What's causing the flickering? Could be anything. Could be a sync code problem. Could be a Vulkan validation error that I've just not caught. Yeah, I don't know yet. I did a silly somewhere. I'll find it, but I think we're going to be sort of, yeah. Like I didn't know that thing actually existed until we actually expanded out the level. This is part of the reason why we're building. We want to be able to build like, kind of a smallish level, so when we do the next rendering improvements, we can make it all work properly. Yeah, graphics programming, woo. Not for another year. We won't be doing graphics programming for another year, but we will. Actually, no, to tell a lie, we'll be touching some shaders. We've got to get some data back from the GPU, but we're definitely going to be building tools to help make the graphics in the game. I'm just programming, and I have an understanding of what you're saying, but I'm burning some RPM trying to visualize it, lol. Very cool project. Cool, appreciate it, sir. No worries. What are you learning right now? All right. You want to avoid star star? Ah, right. It's gonna custom allocate it, isn't it? Oh, with malloc. Oh, I can't believe I wrote this. I look down on myself. Look at it. Ah, malloc. void star star. Okay, so now initialize the CSON reader. The basic idea is the file does start with an array, right? So we basically start doing the array thing. CSON reader array start. Address of R. Yes. Then it ends with an array, obviously. To do that too. And then we obviously want to put a bit of an error message here. Go, well, if there is an error, if r.error message, then an error while reading, be like, oh, pretty neat. So now we just actually parse the rest of the structures out. So here we go. So again, we're not going to be actually hand coding this. We're making a code generator to do this for us. Yeah. So we're just going to do stuff like this. So I think we just do the opposite of this. No. Well, it's kind of similar, maybe. No, it's not bother copying it. So the next thing we do is we read the next field. So I guess we do a while loop. We're kind of saying like while we're reading it. So what happens? We didn't really. That's a good question. So when we do like a next field, like what happens if there isn't a field? Like what happens if oh yeah, if there isn't one, you just return null. We didn't do that though. So we say so what we want to say is like one we should be parsing a comma. No, because that means it will support prefixed commas as well. So really after every time you parse a value, you should also check if there's a comma there as well. That'll solve that problem. So you do the skip white space and new lines, and then you tell it to parse the comma. Where have I done that? Yeah, so this at the end of a strut, we don't need that trailing comma support there. Where we need it instead actually is these places here. Yeah, so one of that. So in float enum. Yeah, so that means the trailing column is trailing comma is handled. So when we parse a field, if we have a open, no, close, yeah, close. We have reached the end of everything, so we should return null. Which errors do that, but it's kind of like an error of set in the error message, so we'll be able to terminate parsing any of those fields or any of the array values because we've finished it. So if we go back to here, so we get the core string. This is the identifier. Now, because this is an array, it could actually give us like stuff that's inside like array literals, like you've initialized element 0 or whatever. There's odd the way they've written this CSON reader is so that like we've got to handle this ourselves. And so I think we're just not going to handle it, and I'll leave it up for a future thing to do because it is a bit complicated. But ideally, in the future, right, we could even support like enum values in here, which would be pretty sweet. You can have an array which is indexed by an enum, and you can store that in the in the text file. It's kind of nice. It's not just 0, 1, 2, 3. So that's something to improve on later with the system. But until we need that, we can just not do it. So just because this is an array, we say if its data is equal to null, we terminate this loop that we're in. You could have gone error actually. It terminates there. Comes out. Or we've reached the end of the array. Now we've processed the field identifier for the array. We can now parse the values. So we do a reader. We don't know what it is, right? What we do know is that strut type, isn't it? So that would be a strut start. But yeah. So we were expecting the structure encoded here to be strut type, right? Because it's an array of structure types. We've stored that in the file, and then we do a CSON reader end, and then again we do another while loop. So we do another while 1, and we are simply just going to repeat the same sort of thing. Right, we set ident to whatever this field thing is. If there was an error or we've finished all the fields, back out. Then this is where the fun begins. I guess we could have read this as like a hash or something, but for now we'll just do like string compares. So if we have got the core string equal, perfect. So we'll pass in ident and then we'll pass in the literal. So the literal being, there's quite a few ones that we put out, right? We put a line, column. Line, column, ident, fields count. Let's read those. So really we should be able to put... So here's what we're going to do, right? We're not actually going to encode it. We're going to assert that we read out the same value because yeah, that's all we need to do here. So here's the actual strut. We can get ourselves a strut index here or something. I don't know. And every time we read a strut, we do index plus equal 1. Then here's the structure we're expecting to match. So say if it equals line. And there will be an else where we go, for abort. Unhandled field. So here we'll actually read out the to be CSON reader. So we'll read back like an actual U64 or UIT as we call it. Pass in the address of the reader, and then we get back our U64. So the U64 value will be here. And we're just going to assert that v is equal to structure location line. Oops. Line mismatch, right? So technically this could error, and this would then set error message, right? But since this is just written for like a serializer, like returning back a value that we don't know is errored or not, we're just going to store it somewhere and then go to the next field in the loop. And then this one will be like, oh, it's errored, and then just bail back out, right? So in this case, it's going to kind of be problematic if this fails. But this will just be like, oh, it's a mismatch. But that's okay. Well, we could just do this. If we got an error message now, all that is equal to that. Cool. So the next one to do is the column. So I think the column was stored as hexadecimal, so you get to see that working as well. And the next one after that is the... There definitely is a fields count. Let's write that one. What else did we do? And then I guess we just did the array of fields. So the other one is the array of fields, and then guess what you do there? You parse another structure, so you begin another one. So it's this all here, basically. But again, so yeah, these will just be broken into their own functions and be code-genned. They won't keep nesting down like this. So you basically parse, you then do a begin strut, field, then you get the next ident. I guess you get the structure field. I guess we do like a field index, and we'll just up the field index every time. Then we'll just say like right strut field. So put a bit of an F in there. S fields field index. And then we'll just parse all the fields that we had in here. So I guess it was just a type. There's a couple of strings, right? It was a string for a type. And an identifier. So we're checking for string equality between the value and the one that's in the structure field, right? Ooh, I gotta call that function. Type string, I think it's called. Let me take the address here. Right, that does it. So that'd be type mismatch. This would be column mismatch. And this would be fields count mismatch. So we parse. There's one more was ident, I think. We'll double check it in just a sec. Write it out quick. Ident mismatch. Wait. Yes. Cool. Looking good. Unhandled field. Cool. There's one more assert we do want to do. And we're going to be like, oh, did we parse all the actual fields back out? So another one of these equality things. And we'll say whether there's an error message. Or if field index, ensure that is equal to s fields count as well. And also that's as a fields mismatch, if not. Cool. So I think that's basically it. Let's just double check. So when we serialized it out, we put a line, column, and identifier. Whoops, I did miss that one. Get that one as well quickly. So there's of course a field ident mismatch. So we put this one in here like this. This is going to be an S ident instead. This will say field like that. Okay. So this should be the code to deserialize that CSON file that we're going to code gen in the future. But for now, all this will do. So, right, C limits not found. The things I program in C++, I pressed something and it was like diagnostics, doing my job. C math. Right, so it's actually in limits.h. So actually we'll go to core.h. We'll include limits in here. So we should try and really remove as much of this as possible, but it's not really a problem right now. Right, so that structure field thing needs an address. Cool. Right, so we did get the error message printed out nicely. That's pretty cool. So apparently said expected this to begin reading structure field of type struct type. We got that. I thought I wrote that parsing code correctly, but maybe not. This course did line 2, column 13. So should we just check that quick? Look at that CSON file. Line 2, 13. Let's run it down here, bottom right. 13. None of them in the way. Yeah. Wait, I'm probably getting more in the way there. So yeah, obviously I did parse that wrong, but it read the type successfully. So let's get back into the CSON strut begin or strut start, isn't it? So we did do, No, I didn't even do the close bracket like a melon. Look at me. I actually generally miss doing it. Right, improved. Let's go. Right, slightly different one this time. Line 7. Hey, Acorn. Aconex. Welcome. How are you? Welcome to the stream, sir. I'm doing good. I think I'm a little bit ill to be fair, but other than that, I'm alright. It just came on all of a sudden. Probably because I had these boys yesterday. Whoops. Too many mangoes. Pepsi mangoes. So line 7. Line 7. Ow. We expect an array here. Right, so I wrote incorrect parsing code. We actually need more indentation. Can you believe? No, we don't. We need to start another array. I forgot the start array thing. It's fine, this will be code gen in the future. No biggie. Fields. Hang on a minute. Start array, end array, end strut. And then with every element of the array, you start a strut. Ugh. Oh, holy crap. Unhandled field. Get it pretty close though. Did we miss something out? I'll be interested to see what this is saying. In, ident, size, ident, yeah. Let's roll. What? Oh, is it doing one of those empty string things? I bet you it is, isn't it? Being published. Cool. I would say my first comment is this background scroll way too fast. It feels a bit jarring. So if you can slow that background down, I think half speed. I think that'll help a lot. Like it's very yeah. But do you publish them on GitHub? Play them on. Cool. Sweet. Let's see. Right. And your GitHub link. Check out your code. That's cool. Yeah. So I guess you're trying to get in. Uh. Huh. What's? Right. Is that better? No. Huh. That's alright now. Yeah, it comes. Yeah, that's cool. But yeah, I guess that's the only really comment I would say. You trying to get into the industry then? Is that the plan? Have you tried getting in already? Like, what do you want to get in as? I guess is my question. Because when I look at this, it's not really telling me like if your objective is to get into the games industry, it's not really telling me about like what you like doing the most. I guess like what is the thing you wanna? Because at the end of the day, the game industry typically wants people specialize. Like, oh, you're hired to be a programmer, right? Like a gameplay programmer. You know, and obviously the smaller companies you wear more hats, right? Um, so I'm just wondering what your to be a programmer. Yeah. So say like um about learning more with each game published, and then say like um say something about how you enjoy the most doing. Obviously, not these exact words, but say you enjoy most doing the game programming side of things, or or you specialize. Say specialize. I specialize in game programming, but um, maybe you can list all the things you have done for your games to say how basically you're aware of these other disciplines, right? Because you have worked on those games. So that gives you more value, right? You are you're training yourself to be aware of other disciplines. So I would say those three things, right? The background, slow it down a bit. Um, this is all okay. Um, you know, these just have to basically have a picture and the game. Maybe these are a little bit too big. I don't know if this is my zoom level. Could you maybe shrink this down a bit so it's the same size as this text, maybe half the size of this picture? Then I guess you would. These are a little bit too big, I think. Because if the text is only this big, well, this is just wasted space. You're making me scroll down, right? You know what I mean? But that's just a bit of a nitpick. Um, yeah, those things. Maybe we should allocate that damn allocator. Um, no worries. Appreciate it. No worries. Glad it helped you. Um, was this missing? Server commit. Point exception. Can't be a divide by zero go. Crap. Page size. Crash. My systems. The pre in it somewhere. Right, now they did proper, right, bit of a stack trace there. Right, so it was using the temporary allocators and they weren't initially. But yeah, so it just has an empty field, isn't it? So why don't we put a bit of a breakpoint in here and we'll have a bit of a see what's going on. Then something silly. So the first item we get is an empty string. Right, clearly a bit too right. Oh, I did it silly, didn't I? That's an array. So I've got to ah do more indentation. I did say that, but I didn't do the right. Parse all the fields. 8. Expected this reading this struct, but got right. So after every single field, should be doing that trailing comma check. So I think we're missing it in those trailing comma checks. We added in, but they were simply just parse the trailing comma. It's there for these values. We need to do it when you end an array as well. You end an array or let's look at line 7 of the file and see. Line 7, right. Column what? 7? Right, so it finishes the strut. Comma. So that should have. Ah, this got paused. I know the problem is. So that thing we fixed would have been the next problem. So basically we do like when we parse a field, we say if it comes across a curly, but that would have actually advanced. So what we actually need to do, go peek, with a cheeky peek, rather than act parent. To turn it into the string, but got this. Is that a null terminator? Right, 1 6. Let's look at the string. Read a string. Read until. Could have been a new line that it got, to be fair. Yeah, maybe we did a new line. The one. Base characters. I put my character there. Don't know what that is. When I printed this out, the CSON. So that's in that type string. The null terminator, is it including the null terminator in this? Right, so there's actually a null terminator in there. So would have stopped. Right, is it including the null terminator in this? Right, this might break something else. Have a look. Does this break the game? Game seems. Yeah, so why then does it still not handle properly? Did it? 1.6. Go back to a bit of a reload. Ooh, still got that dodgy character, but with the. Right. You know what it is? We need the null terminator, but we don't want to. It needs to write the null terminator. So first it measures, adds one for the null terminator. Don't include the. Write it in. Same sort of problem. Given S6, S64. Why is there a valid sort of. It prints out the invalid character in. Like. Maybe it is a space character. Maybe I cat the follow. Scripts. Where is this file at? That root. Yeah, so it hasn't got a character there anymore. But it shows up in the editor. So that must be a null terminator. Huh. Be a null. It goes into here, right? Measures, does the add one. Ah, we do string.size in here. Okay, that was the problem. Okay. Done. Oh yeah, it worked. 100%. Pretty sweet. So let's just double check and make sure it did actually work, right? Because none of the assertions actually. So quickly double check that by like adding one or something. So let's add one to this fields count. Fields count mismatch. So clearly it was executed. Add one to the column. Column mismatch. Now if you see the columns in the actual JSON, you'll see that the column is in hexadecimal. Ours is that. The line number. That one works as well, right? Got an error. So definitely was reading that field. Setting on the version. These string ones are probably also. But we could double check by putting in maybe a grab. And this one errored on this. Cool. Radio, I'm happy with that. It's really good. So quickly, what I'd like to do before we end today is I would like to do the error CSON because the CSON reader got this great thing where basically only check for errors. This break if we reach the end of structure of the array that we've been parsing. So it's kind of been this sort of like silent thing, right? Every function basically checks the error message. So we'll observe it. And we'll go over everything, and if it ends up reaching an error, it'll just loop, go around the next loop. Oh, we found an error. Then we check for the error messages. So I would like to have some writer. So for the writer, it's all pretty silent, really. It doesn't really have any conditions based on any writing. So it could just be as simple as whether we've overflowed. Boolean for 1 lines. A ball in there. So you're going to say error. So we'll say W error. We initialize the writer. But if we try to write these assertions here, and the indents, maximum. Well, the maximum indent is a decision, so that wouldn't be a problem. You would test every file anyway. 64 type index. And we'll keep that as an but it's mainly these overflows. So if not of we're going to simply set W error to true. You know, we could have said overflow rather than let's just do the error message thing. Done it for the copy it. Let's just do it. So there's an error message reader function. Just copy paste. So it's simply just gonna SM Um, so we've got a thing called error message in there now. That should work. Error message first character. Null terminator, right? Cool. So this means we can use this error message to basically encode whatever we want in there. We haven't really got the file paths. Line and column. Yeah, we wouldn't really do it though. The error. Cool, so here we'll do some lovely checks. Be like, if not of that. W error message. JSON writer. Or just, you know, that formatted. Pretty sweet. And we'll have a similar here. String dots. And I guess we'll carry it on to the other ones. Resurgence. Indent thing, which I said I wouldn't do, but give the W indent greater than or equal to. Keep the sad face in. Gotta have his. And then we'll just do the same thing again for this incentives equals 0. Whoops. Incentive more times than it's. Nearly. Oh no, this strut. If you don't put a field in there. See, these ones are like programmer error. Whereas the other one is like a user. user maybe. But still, there was a program error. It doesn't crash the application. Maybe there's another way to serialize it out. We have two serializers. We have a JSON and a binary serializer. Yeah, maybe. I don't know. Cool. Name, size. So now we have. Wait. These are not errors. They're for the reader. Get rid of those. Decrement. Reader decrement. Better. 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 Radio. So we go back to the encoder generator. Now what's super lovely way to set this error message for the reader. Now put that writer before you flush it. If so, write it out. Crap. Error message. Wait, let it go. Right, so apparently that worked. So we hop out to the error message now. We should really actually put over it. Yeah, same thing for the reader at the end. So, or an exit, whatever, right? So for the writer, let's give it no memory. Let's see it. Select, run. Error, JSON writer overflowed, the allocated buffer is 65 bytes. So, obviously it wasn't assertion before, and we did technically kind of do an assert with a print. But the, you know, obviously this means it's now conditional. So we do try to serialize the type out. We can at least have a way to get an error back and display that in the editor if there was a problem trying to save the file instead of crashing and losing work. I know if they can't save something, they might lose work, but it might be some other ways we can solve that, or the user might be able to delete stuff, whatever it is. Maybe save it in the save another part of it. I don't know. We'll figure it out. That's cool. Right, so that's the JSON reader and writer done. So we've still got two more. Still another target to do, and that is a binary serializer. And I would like to get that done because we need to use it for more than just files. It's only going to be used in for files when we do release builds. But where it's going to be used is going to be GPU whenever we get back to doing GPU stuff. So it's good to really get it done another way. So what we're going to be doing is inside this sort of encoder part of the engine, where we've got the CSON reader and CSON writer. We're going to be doing a binary reader and binary writer, where we're going to be packing things down into literally a bunch of bits and quantizing all that good stuff. So we'll start with the binary writer next stream, which will be on Thursday at 8 p.m. GMT. You can check out the Twitch. And then obviously in the stream after that, which I guess will be next Sunday, we'll do the reader. That'll be all the serializers or the encoder, the actual encoder code finished. Encoder and decoder code. Then we can get on to working on the sort of system that's sort of working on the encoded generator symbol and bringing that system together. So that'll probably take another. So yeah, gonna be sweet. Put it out. I see them. That's cool. Right. Let's find someone to raid. So yeah, thank you everyone for popping. Have a good rest of. Hope you have a good Wednesday. Hopefully. Yeah, thank you for everyone who's so far. Really. And I hope you. Let's raid Last Miles. Yeah, come and join the Discord if you haven't already. Yeah, off stream. And yeah, I'll see you on